checking that. It must be the day wants or the fact that I'm not dying yet.
Oh, you're up for pig roast. So I'm going to connect you to Major Maxwell because he's in the math band, and I don't think they're playing for pig roast.
Perfect. I mean, it's a shame they're not playing, but that means
Well, I don't think they have enough instruments. So, anyways.
We got the time. We could probably put together like an augmented band, get down there, like do a little hot swap.
We can certainly bring our group. I don't think they're playing together, those guys. So I thought they were, but you can bring our group. Your keyboardist already learned alone, right?
Yeah. He's probably forgotten by now. We'll figure it out.
I actually didn't like that song, and now I don't mind. I practice it. It's fun. All right, epsilon neighborhood. So some of these things are coming from topology, but in real analysis, you're nitpicky about things. We should have been in topology too, but I feel like it's so overwhelming that you can't. But here you start out with, you're given an A in the real numbers, you're given an epsilon bigger than 0, then the epsilon neighborhood of A is a set, and it's a set of x belonging to R such that absolute value of x minus A is less than epsilon. So let me run through an example. So if I have A equals 2 and epsilon equals 0.01, then the first thing I do is substitute those two numbers in for where they go into the set notation. So I get a set of x and R such that absolute value of x minus 2 is less than 0.01. So whenever I read set notation, and if you had me for foundations, we talked about that. We look at it like, what do members of this set look like? They're members of the real numbers, and such that this constraint is satisfied. So I consider like two bouncers. You're trying to get in the club. The first bouncer says, hey, are you a real number? That's the first pass. The second pass is this restriction here. Are you a real number that satisfies this inequality? So thinking about it further, for x to be a member of the set, it means that that restriction has to be satisfied, which I can expand using theorem 2.2. And that breaks down to the x's between 1.99 and 2.01. For x to be in the set, x has to be between those two numbers. So the students who had me for foundations and topology we looked at things like Borel sets. You got definitions like that, or sigma algebra, sets of sets. Still, you have to go back. You have to go to this fundamental thing of going back and saying to yourself, what is it that's in this set? What do the members look like? What are the restrictions? And try to really understand what's in that set. Those are good principles. It's just like that person that wants to go out and swing the basketball behind their back, but they can't dribble. You got to start with dribbling and get those good fundamentals down and the good habits. All you really need is a good dribble and a good crossover before you do anything fancy. It's not like you can get the fancy part without doing the technical fundamentals first. And so that's what you get out of a real analysis course. I know I'm not tall, but I like basketball.
So the epsilon neighborhood is just like a neighborhood, but with some fixed distance?
It always is. Yeah, it always is. If they say epsilon's arbitrary, then you have to think about it differently. But here, that's what it is. If you think about it with specific examples worked in. When I taught proofwriting classes before, I used to make students memorize an example to go with each definition. And they all said that was actually good. I actually have dropped that from my classes. But you want to always think of an example that you can get your hands on and really understand. That's not trivial as you go through things. We'll do some of that for homework. I'll have you guys do some of that. I also want to see this visually. There's a number line, and I can actually draw that up there, and I can tell you that that black line there is a visual representation of that set.
This is way better than the way Bartle put it. I did not get that.
Great. You're going to love your homework. You're grading them. So this is pretty straightforward. And I'm going to have you go straight to